We're moving a unit backwards quick. We're going to 9.3. We just finished 9.4 on inscribed angles, and now we're moving back to 9.3 for arcs and chords. So please make sure that you have a notebook as well as a writing utensil in front of you. There are, just like last section, there are a lot of key concepts in this one and different rules that you're going to want to write down. So you're going to be able to recognize and use relationships between arcs and chords, and then you're also going to be able to recognize and use relationships between arcs, chords, and diameters. So here's our first example. We're going to use congruent chords to find arc measure. So we have a circular piece of jade hung from a chain by two wires wrapped around the stone. JM is congruent to KL. Those are two chords. And the measure of arc KL is 90 degrees. We need to find the measure of arc JM. This one's pretty straightforward, but just to go through it, JM and KL are congruent chords. We're given that in our description. So the corresponding arcs, JM and KL, are also congruent. Remember that your arcs are congruent to their central angles, and the relationship between our chords and our arcs mean that if we have two congruent chords, we also have two congruent arcs. So because they are congruent, arc KL is 90. We can also state that arc JM is also 90 degrees. So pretty straightforward, easy. Here's another example for you. Circle W has congruent chords RS and TV. If the measure of RS is 85 degrees, find the measure of arc TV. You can go ahead and submit your answer into Edpuzzle. Another type of example is using congruent arcs to find chord length. So now we're doing the opposite. Now we're going to have congruent arcs, and we're going to try to find the length of the chords. So in the figure, circle A is congruent to circle B, and arc WX is congruent to arc YZ, and we need to find the measure of arc WX. So arc WX and arcs YZ are congruent arcs in congruent circles, so the corresponding chords WX and YZ are also congruent. So again, that relationship between arcs and chords, if they're congruent, then the opposite is also congruent. So we're going to have WX is congruent to YZ, the two chords. We're going to substitute in the equation. So 7x minus 2 equals 5x plus 6. Simplifying it to get 2x equals 8 and x equals 4. We know that chord WX is equal to 7x minus 2, so we're going to multiply or substitute in for 4x. So we're going to get 7 times 4 minus 2, 28 minus 2, which is going to get us 26. If WX chord is 26, then the arc for WX is also 26, so we're going to get 26 degrees. I'd like you to try an example on your own. In the figure, circle G and circle H as well are congruent, as well as arc RT and arc LM. I'd like you to take a second and find to find chord LM. Submit your answer into Edpuzzle. So here's our first key concept. If a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Bisecting means that it separates the chord into two equal parts. Okay? It also creates a 90-degree angle. So we're going to use the radius perpendicular to a chord. So in circle G, arc DEF is 150. Okay, so DEF from D to E to F, this whole entire arc is 150. And we need to find the measure of arc DE. Notice that we have a radius that cuts the diameter and the chord perpendicularly. So radius EG is perpendicular to chord DF. So by the theorem that we just wrote down, EG bisects arc DEF. Therefore, the measure of arc DE is congruent to the measure of arc EF. Because it's bisecting the arc, we have a whole arc DEF as 150. We're just going to divide that number by 2 to get that arc DE is 75. That word bisect always means that you're dividing by 2. You're cutting it in half. An example for you to try on your own. In circle Z, the measure of arc WUX is 160, and I would like you to find the measure of arc UX. Take a minute and submit your answer into Edpuzzle. So I need you to pay attention to this, and I also need you to take extensive notes on this part because it's a little tricky. There's a lot of steps. So the ceramic stepping stone below, diameter AB, so this line across AB is 18 inches, and the chord EF, so the side of my square right here, is 8 inches long. And we're asked to find CD, so this middle part right here to the outer edge of my square. So it's probably wise of you to just draw this figure, not as the tile, but as this right here, okay? So here's our figure. Our first step is to draw a radius. You can draw a radius. Notice CD is not our radius because it does not extend to the outer edge of the circle. CB extends to the outer edge of the circle, but we want our radius to be fully in our square. So we're going to use CE. You could have also used CF, doesn't matter. So we have a radius CE, and this right here forms a right triangle in our square, triangle CDE. So that's our first step to solving. We want to solve for CD. So if we make this a right triangle, we know what our radius is because we know what our diameter is. And now we can go ahead and solve and find ED because we know what EF is. And then we can continue to solve for CD. But we're getting ahead of ourselves a little bit. The first step is to make a radius. So our radius here is CE. Our second step is to find our missing pieces, as many missing pieces as we can for our right triangle. So since AB, which is my diameter, is 18 inches, CE is going to be, and CB is 9 inches, which is my radius. All of my radii of a circle are congruent, so CE is also going to be 9 inches. It's just half the diameter. So since diameter AB is perpendicular to EF, AE bisects chord EF by our theorem, so it bisects our chord in half. Because it's bisecting our chord in half, we know that EF is 8 inches, so DE is going to be 4 inches, half of 8. So I want you to take a second and label your diagram that you drew in your notebook. I want you to label your new radius is 9 inches, and I want you to label that DE in EF is 4 inches. So now we're just missing that bottom piece. And to find that bottom piece, we can use the Pythagorean theorem because we have a right triangle. So we can write CD squared plus DE squared equals CE squared. We're going to go ahead and substitute in what we know. So CD squared plus 4 squared equals 9 squared. CD squared plus 16 equals 81. CD squared equals 65. So then CD is the square root of 65, or about 8.06 inches. I know that was a lot of work to do for one little problem, so I'd like you guys to use the same steps and try it on your own. In the circle below, diameter QS is 14 inches long and chord RT is 10 inches long. I want you to find VU. So use the same steps that we just did for the previous example to solve for this circle right here, and submit your answer into Edpuzzle when you're ready. Our next key concept is in the diagram. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So if two chords are equally distant from the center point, then those two chords are congruent. Here's an example. In circle P, EF equals GH, which also equals 24. We want to find PQ. So since our chords EF and GH are both 24, we can conclude that PQ and PR are congruent to each other, equal to each other, due to our theorem that we just stated. So PQ equals PR. 4x minus 3 equals 2x plus 3. 2x equals 6, so x equals 3. In order to find PQ, we're going to go ahead and take 4x minus 3 and plug in our new x. So 4 times 3 minus 3 is going to get us 12 minus 3, which means PQ is going to equal 9. So you're going to use the same steps to solve for circle R. You're going to be given MN is equal to PO, which is equal to 29. So my two chords there are 29, which means RQ and RS are equidistant. So find RS, and once you're done, submit your answer into Edpuzzle. Once you've submitted your answer, this is the last example. So if you need to go back and retake notes, please do so. I hope you took extensive notes. You're going to be given practice problems soon, and those will be up either Tuesday or Wednesday. Thank you, guys.